As we can see here, in our code, we started with, okay, let me run the first part. So there is a digit train for the array data that contains the data uh, of image format of various handwritten digits, right? They are their orientation has been changed, and they are something like having different various orientation. They are tilted by various angles. Okay, so let me run through this next part. So as we can see, when this is running, after we run this part of the code, we'll get the workspace with the train, x train, y train, x test, and the y test data over here. So directly we are reading the data from the predefined or already available data set. Okay, x train and x test are the data that contains the images, whereas the y test and the y train are the results expected. They are something like the tilt angles of each of the image. Okay, so 37 positive, with a convention it has been written. So if an image is tilted to right, it is positive, left is negative. So minus 36 says that it is tilted to the left side, right, 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 left, right, left, 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 and so on, right? By what angle has also been specified over here. So for test and training data, we have already separated them. Okay, that's what we have here. In the next session, you can see that I'm trying to find the total length of my data, right? Numerical length of the y train. So y train has 5000, right? So that's what will come here. And randomly, I'll select some of them for my plot. Okay, so let me run this. So I'll run this. Now we have to see a plot. Okay, so let me show you. So we get a plot like this. So as we have chosen 30 random images to plot, right? We got the plots in this fashion. Is it okay? Right? 30 different plots arranged in five, sorry, I think 1, 2, 3, 4, 6 rows, 5 columns. Okay. Then in the next part, we'll try to see the details of the data set, wherein we try to plot another graph, which is a histogram, showing what are the various angles of rotations we have. Okay, the various angles of rotation we have here, from this we can see that, I'll just bring up the figure. Okay, so as we can see, we have the various angles here. So minimum angle on the negative side, it comes around between minus 40, minus 50, minus 42, minus 45. And on the positive side also, we have a very similar case. Okay, right? Plus 42 plus 45. Between that, we have how many numbers? I'll just click over there to see that values over there. So you can see here, if I click, I should get yes, so 342 values. So similarly, the other side also we have this value. So 0 also there is, right? Between 0 to 5, you have so many values, right? And so on. So like this, we can check that how many values do exist. So totally we have, when you add all the values, you get 5000. So data set is ready. We don't have to actually do the processing of the data, or we don't have to modify the data. Directly we'll define the layers of the network. So image input layer, right? We have the convolutional layer, batch normalization, etc. Right? So you see image input layer because input is image. Then the convolution, batch normalization, ReLU, and the pooling, average pool. This is what has been repeated once again here and another time, right? So, and the final layer you connect, you add a dropout, 20% dropout, and a fully connected layer output is only one, and a regression layer because you are supposed to calculate what is the tilt angle of the given image. Then we define the training options, as you can see here, right? We have the specification of the validation data as well. Then we do the validation and we should be able to see our output. Okay, right. So let's start with the training part now. So since we have opted for the verbose, it's going to show you on the command window. We should be able to see the training progress. Okay. Also, we have opted for the training progress graph. We should also be able to see the training progress, right? Both will be visible. We can see that the RMSE and the loss functions are continuously reducing as the uh, training progresses. So we can see 100 epochs are over and the net can also be seen, right? So also I'll bring up the training progress window so that we can see that the training got completed in this fashion. Okay, so validation RMSE is 1.84, right? That's the detail. So it totally took 8 minutes 4 seconds. Okay. And okay, so then going ahead with the code. So now I would like to visualize the network. Okay, so that can be, in order to see that, what I do before this, I'll write another code that net dot layers. I want to visualize the layers in this fashion. Okay, this is the other method which we know. Let's try to see whether we can see the layers. Yes. So over here in the in the command window, in the command window we can see the layers defined. There are total 18 layers we have defined, and the details are also, as you can see, right? Input layer takes 28 into 28. Convolution one layer is 8, 3 cross 3 cross 1. Similarly, you can see all the details. Okay, that is just optional case, but I just wanted to show how do we see. Okay. So now I'll go for the predicted part. I just want to see the prediction. Okay, so y predicted is equal to y predicted is equal to this. Now what I do, I will not look at the predicted answer directly. What I do, I try to calculate the error in the prediction. Okay, so that is prediction error is equal to, so y, I think we gave the name as y test, right? Whatever is a y test, subtract from that y predicted. So that will give you the prediction error, and with some threshold. Let's say that, okay, it may not be very accurate, so let's give a threshold. Okay, threshold is equal to, say, 5. This is 5 degrees. Up to 5 degrees, if you have an error, don't consider that as an error. Otherwise, you consider that as an error. Okay, right? So correct answer is equal to the sum of absolute value of, because it can be -5 or +5. I want to keep any value lesser than that. I want to say that it's a correct answer. Okay, so the prediction error, absolute value of the prediction error, if at all it is lesser than the threshold value, that will be a correct answer, right? So what we'll do, I'll also check the number of testing image. Okay, so directly we can go calculate the accuracy. Accuracy is equal to number of correct answers, that is correct answer. What I should divide? I should divide by the total length, right? Length of the testing image, that is numerical length of the y test. Now let's check how many are correct. What's the accuracy? So we can see the accuracy here. Accuracy is 79%. Okay, so that is, we took as a just 5 degrees. If any, if the regression is right, if the deviation is lesser than 5, then only we took it like that. Okay, let me change this. All right, so let me take it as 10. Let's see, will it increase? I am expecting it to increase. Now you see the accuracy all of a sudden increase to, it depends upon our, what is the amount of error you are allowing the machine to do. You see it is 97%, right? If you say that, okay, if your guess is plus or minus 10 degrees than the actual value, I will take it as a correct answer, but that may not be acceptable. Let's keep it as, say, 5 itself. Okay, right? Machine can make an error of plus or minus 5 degrees. So 25 degree was a tilt. Machine can guess it 20 degrees or 30 degrees. Anything between that, we'll take it as right. That's fine, because if I make it, this is 10, right? It becomes 10 on one side. So both sides is 10 plus 10, 20-degree error margin, right? That may not be accepted, right? So that's why I'd like to keep it. Let's try to reduce this. Say, I just want to have a 2 degrees, right? Accuracy will reduce now. See, the accuracy is just 38%, right? Depends upon what we consider. So let's keep it as 5 itself. And let me run that. Okay, so accuracy is this much. So anyway, we calculated the accuracy. Let me run this section again just to confirm. Yeah, 79.06. And let me also show you how to calculate the RMS E, right? That error value also I want to show. Okay, how to calculate that. Uh, so first let's calculate the square values, because RMS E, squared error. So it's a prediction error error should be squared, right? Dot power 2. So this is the squared values of error. So how do you find out the RMSE? RMSE is square root. Yes, it's not. It's SQRE, the square root of RM. M for mean, right? So mean, square root of mean of the square values. Now you see, I'll run this part of the code so that see there is an error of 4.2. Okay, now let me show you another part. I want to have a see this whole the objective of this code was to understand the process of what is called as the regression, how the machine performs the regression. Correct. So let's see the regression. Regression in the sense you are trying to fit a curve that matches the given data. Correct. So I should be able to visualize that. Yes, right. I'm able to see what you call the predicted value. Okay, right. I should be able to see that. So let's try to do that. So I'll call another figure and I'll go for a scatter plot of the predicted versus test value. Okay, so that is y predicted and this is this is uh, y y test. Okay, y predicted, y test, and this has to be a plus. Okay, let me try to mark it using a different okay, then x label. What will be the label? Let's give it as predicted, and y label is truth. Okay, let's try to plot this, then we'll see. Right, so this is what is the plot. You can see that all the data actually forms a straight line. Correct. Right, I actually machine should be able to predict that the values are lying on a straight line. Okay, now we'll try to visualize that as well. So I'll try to hold on plot, say from maybe it is minus 60 to plus 60 for x axis, x values. Okay, I also want to plot minus 60 to plus 60. This is for the y values, and let's go for red dash. Okay, now we will be able to visualize. Okay, so the straight line, right? We can see that in the red color. Right, that's what the machine actually has learned. Okay, fine. So this is just a plot just for visualization. Anyway, previously we understood that machine has learned something. Okay, now what if I want to correct that? Okay, I want to right. So I said that the machine has learned something, but I didn't I want to check that when the machine knows that what is the amount of tilt present in an image, it should be able to what you call restore that. Should be able to restore, correct? All right. So let's try to go ahead and do that. So let me try to define index is equal to, let's try to define a rand firm of, so number of images we have already calculated. Let me just calculate that. I think that is out of the testing image. I just want to check. Okay, so it's a numerical length of y test. Let me pick up out of that. I want to pick up say some 49 images, right? It's 7 into 7. That's why I'm taking it as a 49. That's my index. And for, let's go for a for I is equal to, starting from 1 till the index, right? Numerical length of index. Let's do this. So image is equal to x test of, so it's a 4-dimensional data, comma comma all, and it is the index of I. Prediction angle. So the predicted angle is nothing but the y, it's a y predicted of that index. Okay, right? So we had calculated, this is the predicted value for the given image. So I'm reading one image. Okay, that image, corresponding to that image, what is the machine's predicted angle that comes here. So what I have to do, I have to perform a restore, right? I have to restore the image. So we'll call it as uh, restored restored image is equal to, or okay, it's a 4-dimensional data. I have to mention that it's a 4D case. All rows, all columns, all pages, and the index of, okay, this is equal to, right? There is a function called I am rotate. I'll show you that. Okay, so this is how it's going to look like. You can check that using the help function. Okay, help I am rotate. It is used to rotate the image, right? Image the rotate, which image you want to rotate, you mention, and the angle you mention. That's all. Okay, there is also, you have an option to rotate it by using a specific method that is called as a nearest for nearest neighbor interpolation, bilinear for bilinear interpolation, and bicubic for the bicubic interpolation. So out of which now we are going to use the bicubic interpolation. Okay, and also you have another method that says that whether you want to keep it loose or crop, in which right now we are going to use the option crop, because make the output size same as the original image, right? Whatever, that's the relationship between the input and output image sizes we want to keep. That's why, right, I'm trying to use. So I am rotate, uh, which image I want to rotate. I want to rotate the image I read just now, so that is image. Okay, and you see the second option I want to enter is by how much angle, so that is prediction angle. Okay, so that will be the prediction angle. Then I have a method. The method of doing this, it is as I suggested, by cubic will be selected now, and I want to keep the size same, so crop. Is it okay? Then I'll say what I can do. Yeah. So let's end the for loop. Let me just check whether this is going to work. It says that there is. Okay, so equal. That's my mistake. So for I equal to. Yeah, looks fine. I just have to plot, right? I got the result. What I do, I'll show you the original image and the restored image. Okay, so we'll call a figure. And the plot. I just want two subplots, okay? 1, 2, 1. And we have an option to club all the 49 images into one place. That's by using what is called as a montage. I'll just show you the meaning of that. So let me clear this. Help MONTAG. Display multiple image frames in a singular rectangular montage. So I actually have selected 49 images, right? All the 49 I want to put it into the same, right, image, same subplot. Okay, so that's why it is. So the function is montage. Okay, so montage, my X test, all the rows, all the columns, all pages, and index of I. Not I, because just say index is enough. All the integers I am supposed to plot. Okay, so this has a title called original data, right? Then I'll go for a subplot 1 to 2, 1 row, 2 column, second place, right? We'll do the montage again. But here I'm not going to show the X test. I'm going to show the restored image. Okay, restored image. Image restored will be completely present, I guess. So I don't have to show it. Let me check whether this works. Okay. So title is the corrected. All right. Let's check whether this is going to work. Okay, but the corrected images are not clearly visible. We are getting an answer, but you can see. Yes, it's yeah. Okay, see the corrected image. It's not showing the proper values, right? Because original images, you can see that they are tilted. Okay, but the corrected ones are not proper. Okay, right. Let me think of how do I rectify that. Okay, so but anyway, the method is clear, right? How do we apply? Okay, so I'll see how to plot that corrected images properly, right? And I'll update you back.